Welcome to presentation of windowing filter for the subject digital signal processing uh, BERT 3373. So in this video we will going to explain to you how and what is the windowing filters. These are the group members for this presentation. First is myself, Amaran Analaki and Rahman, and my matrix number is B122410436. And my partner, Nurul Izzati binti Rahman, and her matric number is B122410522. Okay, so for the first part is the introduction for the FIR filter. Actually, FIR filter are very popular in digital signal processing because they are stabilized and linear phase filters. But the design of an ideal FIR filter cannot be done since it is impossible to produce an infinitely long impulse response that is ideal um, frequency response. To surmount it, the ideal impulse response is truncated with the help of windowing techniques, which is suppress undesired artifacts like spectral leakage and also the side loop levels. Right. The next is objective. In this presentation or in this assignment, there are three objectives. So the first one is to learn and the idea and the aim of windowing in the designing of FIR filter. So for the first, we can know what is the windowing filter in designing FIR filters. We will have the idea and also the aim of the windowing filters. Secondly is to illustrate the properties and the mathematical model of the Hamming and Blackman Harris windows. Before I go further, I would like to say that the windowing filter that we choose for this assignment is Hamming filter and also Blackman Harris windows. So we will illustrate in the upcoming slide. We will show the illustration of the properties and also the mathematical model of these windowing filters. And the third objective is to design FIR filter based on both the windowing methods.
Hi, my name is Izzati, and this one I want to present what is window filter. First, ideal filter have a sharp cut-off by equally an infinitely long impulse response. Direct truncation cause the continuation leading to spectral leakage and high side loop. Third, window functions smooth the truncated impulse response. For window reduction, leakage, and control side loop level. And lastly, FIR filter is analyzed by multiply the ideal impulse response Hn window Yn. And this one the formula Hn equal Hdn multiply Yn. Next, type of window filter what we choose is Hamming window and Blackman Harris window. For Hamming window, definition Hamming window is used in DSP to reduce spectrum leakage. Second is apply moderate temperature to minimize bordering discontinuities and provide a good balance between side loop reduction and frequency resolution. For graph Hamming window, we have AZX for amplitude and ACY and sample. And this mathematical formula for Hamming window filter. This formula has only one cosine term, so that is result into a smooth node bell-shaped curve with rounded edge. This is characteristic for Hamming window. A. Main loop width. Hamming window moderate width. The main loop of Hamming is narrower than that of Blackman, yet broader than the main loop of Hand. Second, good frequency resolution to move to most useful filtering application. B. Side loop attenuous. Attenuous of side loop of about 41 dB. Second, more accurate to Blackman but fair per preferable to rectangular window. Third, the side loop. The first side loop is reduction by construction, and this is primary strings. C. Spectral leakage control. For this characteristic, highly linked as much as simple window, commonly used when a moderate reduction of leakage is re- reduction required. And D. Effect on filter performance has a smaller frequency response than the rectangular window of Bartlett window. Need balance between clean side loop and that which is reasonable.
Okay, now I'm going to explain about what is Blackman-Harris window. It is so a cosine-based window function adopted is the Blackman window. It is an ideal impulse response which is smooth and tapered by a window. The shape of the window will become steadily smaller at the two ends of the window, effectively reducing the number of discontinuities and giving a more desirable frequency response. The Blackman window is also commonly applied where spectral measurements accuracy is extremely important because it is good leakage of reduction. For the next part is about the mathematical formula. For a window of length n, the Blackman window is defined as shown in the slide. Wn is equal to 0.42 minus 0.5 cos in bracket 2 pi n divided by n minus 1 plus 0.08 cos 4 pi n divided by n minus 1, and the small n is equals to like 0, 1, 2, and etc etc. So the formula combines two cosine terms to create a strong tapering effect which significantly reduce the side loop levels. Now we are going to see about the characteristics of the black Harris window. So the first one is main loop width. The main loop width is the Blackman window has already a relatively wide main loop which causes the reduced frequency resolution, and this is the trade-off for improved side loop superposition. And the second one is side loop attenuation. Provides very high side loop attenuation which is negative 75 dB. One of the best windows for the minimizing spectral leakage, and it is better superposition and hand or hemming windows. The third one is transition smoothness, which is hardly leaks as much as simple windows and commonly used when a moderate reduction of leakage is adequately required. And the last one is the effect on filter performance. Its strong tapering at both ends ensures minimal discontinuities and produce a smooth time domain shape. The next part is about the coding in the MATLAB. In this part, we will show you each part by part how we do the coding in MATLAB for the uh, Windows filter that we choose. this is the coding, which is to generate the filter. If we not use this one, there is the output of the Hamming and Blackman Harris window will be not get or not accurate. So this is the coding that we use, which is the frequency sampling is 8000, cutoff frequency is 1000, and n equals to 51. So as you can see, this is the coding for the generate filters. Okay, now this is the next part for the main coding part for the two filters that we choose. So as you can see, it is actually we have a long coding. This is just two, and after this also we have some slides for the further codings. So I explain briefly, which is as you can see the frequency sampling we choose is 8000 hertz, which is the rate of the sampling rate for the system, and the cutoff frequency is 1000 hertz. It is desired cutoff frequency of LPF, and the n is equal to 51, which is FIR filter length, which is ode to symmetric filter, and the m is used to center the impulse response, and the small n is equals to the sample index. This equation is the sync function, which represents ideal LPF. Therefore, at the k equals to 0 is the value replaced with. So as you can see, it is for the plot the time domain windows bubble. So we will get the output. We are labeling all the outputs in the graph later on. So to figure it out, we subplot the subplot is 311, and the title we put is ideal impulse response HDN, and the X label is the sample index N, Y label is amplitude. For the subplot 312 is the title is Hamming window, and as you know, X label is sample index and Y label is amplitude. And for the um, plot frequency response, figure plot half Hamming line with hold on, plot half magnitude dB line with 1.5 grid on, and we set is the color we set that for that one, and also the title we use is frequency response dB Hamming versus Blackman Harris. X label is frequency hertz and Y label is magnitude dB, and the legend is Hamming and also Blackman Harris. The last one is for the plot frequency response, which is the linear one. We also put the coding as before this, and we set the color also for this, and the title for this graph is frequency response linear Hamming versus Blackman Harris. Y label is frequency hertz, and Y label is magnitude. So, FIR LPF design is using the windowing method. For the Hamming one, it is the better frequency resolution and it is faster transition. By the way, for the Blackman Harris window, it is a superior side lobe suppression and better noise reduction. And also, it is a window which is choice depends on application is required.
Next, I show you about output MATLAB. For first output is time domain window is top plot idea impulse response HDN, discuss how the impulse response is designed and its purpose is filtering or signal processing. And this one explain the rule of the ideal impulse response in shape signal. For second middle plot, Hamming window. Hamming window is introduce window function in signal processing, and discuss how the Hamming window help in reduce spectral leakage and improving the frequency response of the filter. For bottom plot is Blackman-Harris window. Similar to the Hamming window, the Blackman-Harris window provide better performance in reduced side loop in the frequency domain, and explain why you choose this window and how it's perform relative to Hamming window. Second graph is frequency response in dB. Frequency response compare the frequency response of the Hamming and Blackman-Harris window. Discuss their behavior in terms of the magnitude and how they affect signal processing. Impacts the difference in the steepness of the roll-off and the attenuation in the passband, which is determine the filtering efficiency and quality of the result. Third, frequency response in linear show the linear scalar frequency response of both window. Explain that this plot give a clearer view of the transition region and highlight the trade-off between window type in terms of filter sharpness and ripple. Lastly, signal output. For this, show the original noise signal alongside the filter output with Hamming and Blackman-Harris window. Discuss how each window reduce noise and the effectiveness of the filtering process, especially in terms of signal clarity.
Okay, now is the application for the Hamming window and also Blackman-Harris window. So spectral analysis, which for the both is first is Hamming window. Hamming windows one is employees spectral leakage reduction in the frequency analysis (FFT), and it provides a good side lobe superposition. Hence, it is ideal to analyze signal whose accuracy requirement is moderate. And for the Blackman-Harris, used to obtain accurate amplitude measurements in frequency analysis (FFT) because it reduces leakage significantly. And high precision FIR filter design suitable for FIR filter design where low side lobe level and clean stop band performance and are more important a narrow transition band. For the speech and audio processing for the Hamming window assist in the maintenance of signal characteristic as well as the reduction of distortion at the frame boundaries. And for the Blackman Harris window, audio and measurements is used in microphone calibration, sound pressure level analysis, and acoustic measurements where precision and low leakage are required. For the last one, which is the conditional and vibration control, applied in vibration analysis of rotating machine in the structural measurements and sensor measurements, it is decrease noise and leakage which enable more pronounced frequency content to be identified. And last one for the Blackman Harris window is scientific and engineering measurement system. It is ideal for measurement instruments such as oscilloscopes and spectrum analyzers that demand high accuracy in detecting small frequency components.
Overall, for conclusion, the assignment create FIR low pass filter with the Hamming and Blackman-Harris window and worked with each window converting into FFT and simulating result. The result of the assignment demonstration that Hamming and Blackman-Harris window give moderate attenuation of the stopband and strong attenuation of higher frequency. In general, the Blackman-Harris window was the most successful in frequency isolation and spectral leakage.
That's all from us. Thank you.